Welcome to Brain Vision.
So here we need to find the perpendicular distance through which the weight is acting. So we can see that D is going to be equal to r squared minus r minus h squared to the 1/2 power. This is simply due to Pythagorean's theorem. So this would be equal to 2rh minus h squared all to the 1/2 power. And we know again that this is in rotational equilibrium. So the net torque is going to be equal to 0. And this would be equal to the force times the r minus h minus the weight mgd. So we can say that the force is going to be equal to mgd divided by r minus h. And so we can solve and say F is going to be equal to mg. Now we're going to substitute D in for this equation. So we can say 2RH minus h squared all to the 1/2 power. And then this is going to be divided by r minus h. This would be the force at the center of wheel. Now, if we want to find the force at the top of the wheel, we can say that for, this is for A. For part B, we can say that F of 2r minus h equals mgd. So this would be the top of the wheel. And again, F is going to be equal to mgd over 2r minus h. And again, F is going to be equal to mg 2rh minus h squared to the 1/2 power divided by 2rh. And this would be, again, top of the wheel. So they're asking which one is greater. Well, we know that the denominator for the top of the wheel is going to be greater than the denominator for the center of the wheel. So r minus h is actually less than 2r minus h, of course. Therefore, the force at the center will be greater than the force at the top. That would be your answer for part C. That is the end of the solution. Thank you for watching.